Next, entering and running the PLC program. This one shows the block diagram of entering and running the PLC programs. Here SLC S5/05 CPU. These are several positions, several programs, several instructions are marked here. The first one is run, RUN run, having a specified box. FRC force having another specified box. FLT filter another box. ENET entered another box. BATT another box. RS232 another box. This one is the run program. This one is REM. This one is programming. So what is programming? Programming is to enter the program into the PLC, place the processor in the program mode and enter the instructions one by one using programming device known as PROG program box. By pressing the enter program into the PLC, place the processor in the program mode and enter the instructions one by one using the programming device. Second one is run. To operate the program, the controller is placed in the run mode or operating cycle. These are the several things are marked here. Next, PLC operating cycles or program logic controller control systems operating cycle. This one is the cyclic operation of PLC programs. This one is for IO scan. This one is the program scan. So when we goes from this point and enter into this point, the whole cycle does form nothing but the operating cycle. During each operating cycle, the controller examines the status of input devices, execute the user program and changes outputs accordingly. The completion of one cycle of its sequence is called scan. Scan means the completion of one cycle of this sequence is called scans. Means suppose we start from this portion or return back to the original position, the sequence thus follow known as a scan. The scan time, the time required for one full cycle, provides a measure of the speed of response of the PLC. PLC operating cycle as pressure switch, temperature switch, motor starter coil, manual push button. The pressure switch, that is I/1, temperature switch I/2, motor starter coil O/1, manual push button I/3. The coil O/1 is energized when contacts I/1 and I/2 are closed, or when contact I/3 is closed. Means the coil O/1 is only energized when both the contacts I/1 and I/2 are closed, or when the contact I/3 is closed. Either these two are at a time closed or only this bottom is closed, then the motor starter coil is energized. So the motor energized conditions of the motor starter coil depends upon either manual push button switch independently or both the operations of I/1 pressure switch, I/2 temperature switch. Either of these conditions provides a continuous path from left to right across the rung that includes the coil. Modifying a PLC program. This one is the ladder diagrams, the PLC ladder logic diagrams for modified process. This one is the pressure switch depended by I/1, temperature switch represented by I by 2, motor starter coil represented by O by L, manual push button represented by I by 3. So if the PLC is used, if a PLC is used, no rewiring is necessary. The inputs and outputs are still the same, and that is required is to change the PLC program. So the above block diagram shows the ladder diagrams, the PLC ladder logic diagrams for modified processes. Then PLCs versus personal computers. So what is the difference or differentiation between program logic control systems and personal computers? The same basic and architectures. The PLC having same basic architectures, and suppose taken here a computer having same basic architectures. So how we differentiate? So what is the difference between PLCs and PCs are clearly marked here. One by one. First point supposed to be PLC. So PLC operates in the industrial environment. Means PLC is exclusively used for industrial applications or industrial environment. But the PC is capable of executing several programs simultaneously in any order. There is no order necessary for executing the several programs by the PC, because the PC is capable of executing several programs simultaneously in any order. Then second bit of PLC, that is PLC is programmed in a relay ladder logic. Means PLC is programmed, PLC is executed in due to the relay ladder logic systems. Without relay ladder logic systems, the PLC program is meaningless. Similarly, but in case of PC side, some manufacturers have software and interface cards available so that a PC can do the work of a PLC. As in PC, there are several manufacturers of several softwares and interface cards available so that a PC can do the work of a program logic control systems. So then the PLC has no keyboard, but the computer having keyboard. No CD drives, but the computer having CD drives. Having no monitors, but the computer having monitors. No disk drive, but the computer having disk drive. Has communicates ports and terminals of input and output devices. Has the communications ports and terminals for input and output devices. So some manufacturers have softwares and interface cards available so that a PC can do the work of a PLC. Has communications port and communications and the has communications ports, has terminals for input, has output devices. But these three items are not available in personal computers. Then PLC size and classifications. First come to depending upon the criteria, the number of inputs and outputs or IO count must be numbered. Second is the PLCs having several costs, and then the physical size is also less. Nano PLC, smaller sized PLC, handle up to 16i by 0. Then this one is the two different PLC size, input output IO count, which are marked in two different figures. Then PLC based control systems. How? the PLC will be operates due to the introduction of program logic controllers. The advantage is the PLC having lower initial cost, less proprietary hardware. Third one is the straightforward data exchange with other systems. Fourth one is easy speed information processing and easy for customizations. These are friendly systems which are being easy for customers, speedily information process, straightforward data exchange with no other devices, less priority hardware and software required, lower initial cost. Next, PLC size classifications. Allen Bradley SLC 500 family handles up to 960 I/O points. Allen Bradley PLC 5 family handles several thousands I/O points. As the Allen Bradley having supposed to be SLC 500 family handles up to 960 I/O points. Same ILC Bradley PLC 5 family handles several thousands I/O points. So both are operates by following two families, that is SLC 500 files and PLC 5. Handles several thousands of I/O points. Next, PLC instruction set. The instruction set for a particular PLC type lists the different type of instruction supported. So this one is the line for controlling the instructions. Here several instructions are marked here. One is user, beat, timer / counter, compare, computer math, etc. So these are the instructions. This is the user instructions. That is the beat instruction. These are the counter and timer. This is compare. This is compare or math. An instruction is a command that will cause the PLC to perform a constant point. An instruction is a command that cause a PLC to perform certain predetermined operation. The typical instructions. While we go through the PLC subject, where there is very much idea regarding this, XIC means examine on. Examine a bit or an on condition. XIO, examine off. Examine a belt for an off conditions. OTE, exchange, output organized, turn on a bit, non-retentive. Next, OTL, output latch, on latch a bit or retentive, a latch, a bit, retentive. Next one is on latch, bit, retentive. Third one is BTF, turn off delay. Turn on delay time. The turn on delay time of on after its rung has been on for a preset time interval. CTD countdown, the use of software counter to count down from a specialized value.